Selena is driving to visit her grandmother who lives 325 miles away from Selena's home. She travels an average of 60 miles per hour. Identify the independent quantity and the dependent quantity in this problem situation. So I want you to think back about what you did, but I'm going to quickly go over it, okay? So your independent quantity, oh, look at all these options. Okay, your independent quantity is time, and it's in hours. Now, how did I know that? Because she travels an average of 16 miles per hour. I'm trying to highlight it, but it won't let me. So when you see miles per hour, that means it's dependent per independent. So I know that our independent is hours, which is a measure of time. So hours, time. And then the other one is got to be miles. Miles is a measure of distance. I guess it could be height too, but we're not traveling miles into the sky. We're not flying on an airplane here. We are talking about driving 60 miles per hour. So it's distance in miles, okay? It's also a distance because her grandmother lives 325 miles away, like a distance, as opposed to 325 miles high. That doesn't make any sense. So independent time in hours, dependent distance in miles. Next, or any questions? By the way, if you are talking about the number and you don't have service to text, that's totally fine. Just email me. Use the internet and email me on my school email. That's another way to contact me. Okay? If you were absent Monday, just follow along with this. Make sure you do this on your own time though, because it's still due for you. Take a look at this vertical line. Vertical lines are not a function. You draw a vertical line through your vertical line. Remember the vertical line test? If you draw a vertical line here, it is gonna pass through all the points. Not just two, but like infinitely many points. Not a function. This, draw a vertical line, you can see it passes through 2 times. Not a function. This one, if you draw a vertical line, it only passes through once. This is a function. Specifically, that is a quadratic function. And then this one, also a quadratic function. This one is a linear function. So here is our final answers. These 3 are functions, quadratic, quadratic, and linear. And these 2 are not functions. That's just a vertical line, and that one's a sideways quadratic, but it's not a function. Any questions? The test is next class. So Thursday for you guys. And dang, I'm so sorry. I didn't know there was a waiting list for the hotspot. I'm sorry. Okay. Next question. Identify the function family of a graph that is made up of curved line and can be increasing or decreasing. Okay, so this is going to be, it's not increasing and decreasing, okay? It says or, so it's just one, okay? If it's just one, we only have one curvy graph that either only increases or only decreases, and that is the exponential graph, or exponential function. Oh, good. Good job, Michael. All right. Any questions? By the way, yes, the test is next class, so Thursday. But I know you guys are probably going to be scared, but just know that if you do really badly on it the first time, you can always take it a second time if you do more review problems. Hopefully that helps calm you down a little bit, knowing that you have a second chance. And so with those 2 scores, if you choose to retake it, I will average the 2 scores. Okay, so you'll get on your gradebook, it'll be somewhere in between your first and your second score. Now that being said, a score doesn't define like how much you know. I know tests, they're just hard for some people, you know? Some people are just not test takers, and that's okay too. All right, just want you to know that. Okay, number 4 is identify the function family of a graph that is made up of line and can be increasing and decreasing. Notice that this one says and, so it does both. So which one's made of straight lines and does both? That would be a linear absolute value function, okay? So it's the V-shaped graph. V-shaped. I don't know if you can see my camera. V-shaped. Okay, let's take a look at the next one then. Oh, by the way, also to remind you, you get to use all your notes. Any notes that you have written down, you can use them on the test. And if you don't have written down stuff, like any handouts that you did on the computer, like worksheets, or like anything that's on the Google Classroom, you can use it on the test. Open notes, okay? Open notes, just so that you know. Open notes, and you can do retakes. So I hope that helps take away some of the anxiety for some of you, because I know test taking is not fun, right? Test is not fun for anybody. So hopefully that helps calm you down, especially in this crazy year that we have here, right? We're all just online. I don't even know what half of you look like. So, I just want to make sure you guys feel okay. And anything I can do to help you guys, I'm trying. All right, number 5, identify the function family of a graph that is made up of smooth curves and can have a maximum or minimum. So there's only one graph that's curvy, but also has a maximum or minimum, and that is the quadratic function, the U shape, okay? Next one. Okay, let me fix the attendance really fast. I'm gonna pause. Identify the function family of a graph that is made up of smooth curve and can be increasing or decreasing. Notice that it says or. I feel like we've done this one already. So this is a exponential function. So it's like the curvy L-shaped graph. It either only, I don't know which way you're gonna see this in the reflection. It either only increases or only decreases. So exponential. Next. Classify each function as increasing, decreasing, or constant. I want to remind you guys that also on the test, you are allowed to open a new tab and go to desmos.com. In fact, if you don't do this, the only reason you should not do this is because you've already memorized what these functions look like. So I don't know about you, but I don't think you have all of these memorized. So this is negative 5 to the power of x. So I'm going to go over here, negative 5 to the power of x. Let me show you. If you don't know how to type to the power of on your keyboard, it's Shift and 6, and it'll let you type on the top, okay? If you didn't know that, there's another way. You can press the keypad, and you can press the A to the power of B, and it'll let you type up there. So I can type X. Now we take a look at this graph. It's going down, down, down to the right, so that means it's decreasing. Okay, so this first one, take a look at it again, is decreasing. Yes, you can use Desmos on the test. Please do if you need to. If you don't know what a graph looks like, pull up Desmos. Do it. Use your notes. Use Desmos. And if you don't do well still, study more and take your test again. And I will average your 2 scores. And hopefully all of that together will help show you that maybe we can make this year a little less scary. Okay? 1/5 x. I know you can't see it. I don't know what happened. 1/5, that's a fraction. 1/5 x. Let's take a look at that one. You can also just type on the next line. 1/5, oops, x. Ta-da! So this blue line, you can see it's blue. Going up, up, up to the right, this is increasing. So I'm going to drag it to increasing. The next one is f of x is equal to 2 to the power of x. There's too many graphs here, so I'm going to take some away. 2 to the power of x. Notice it goes up, up, up to the right, which means it is increasing. Drag it to the increasing. Okay. And then next one is negative 0.9x. Negative 0.9x. It goes down, down, down to the right, decreasing. And last but not least, f of x equals 7. You might notice that if you just type, oops, if you just type 7, nothing happens. So if that ever happens, type f of x equals 7, and then it should help. And you're like, oh, I don't see it. Zoom out. Sometimes that's the problem. Ta-da! There it is. And this is flat, 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 still flat. It is constant. There is not a recorded video yet on how to use Desmos, but I suggest you go play around with it tonight, and then on the test, if you're having trouble just typing in Desmos, you can just call me over and I'll help you. Like, I'll put you in a breakout room and I'll just help you use Desmos. I won't give you math test answers. I will help you type into Desmos, if that makes sense, okay? But if you don't know how to use Desmos still, play around with it tonight, tomorrow night. Next. Okay, determine whether each function has an absolute maximum or absolute minimum. If the graph has neither an absolute maximum or an absolute minimum, choose none. Okay, so we're gonna type these into Desmos again. -8 absolute value of x. -8 absolute value. It's right here, okay? Can you see? X, and click it again so it closes it. And take a look at our graph. It is an upside down V, and this point right over here, this point is our maximum. It's a maximum because it's higher than everything else on the graph. It's higher, so it's our maximum. This graph has a maximum. Okay. Next one is, hold on, let me let someone out of the waiting room, so I'm gonna pause recording. All right, the next one is f of x is equal to -7x. So go over here, -7x, and you can see it goes down, down, down. It doesn't have a high point because if you keep zooming out, it just keeps going. So it doesn't have a maximum. It doesn't have a minimum. It just keeps going in both directions. So this is none. It has neither. Drag it to the none. Okay. And then there's 3x squared. So let's type 3x squared. Let's get rid of that. You can open up the keyboard here if that helps you. You can type 3x, and then to get squared, you can use either of these. If you press this one, it gives you the 2 automatically. If you press this one, you have to type the 2. So 3x squared, and you take a look at our U-shaped graph, and over there, that point is lower than everything else on the graph. So this is an absolute minimum, because it's lower. So this one has an absolute minimum. Hello, let me drag. Thank you. Okay, and the last one is f of x is equal to 4 to the power of x. Let's go do that one. 4 to the power of, remember we use these, okay? A to the power of b, and then you can type your x in there. And then let's take a look at it. It goes up, up, up to the right, so there's no maximum. If you keep zooming out, you can see it keeps going up. There's no maximum. And then on the left side, notice it is getting flatter, and it's kind of going down still. I know you can't see it going down. It looks like it's flat, but remember the secret to this exponential type of function is it continues to go downwards here. So actually, there is no minimum either. Even though it looks kind of like that might be a minimum, it's not. It's not a minimum. It continues to go down to the left side, so it keeps going lower and lower. It just continues going lower forever. There is no minimum. So drag that to the none. And that's this one. Let's go to the next problem. Classify the function as a linear function, a linear absolute value function, a quadratic function, or an exponential function. Once you see those bars, remember according to our graphic organizer that we did, what, like 2 weeks ago? It's on the Google Classroom. So you don't remember, you can always go to graphic organizer answer key and take a look at that. There's an answer key here. You can use it on the test. It will tell you that anything with these bars on it, that is a linear absolute value function. In fact, those are called absolute value bars. Okay, let's go to the next one. Classify the function as a linear function, a linear absolute value function, a quadratic function, or an exponential function. Once again, when you look at this thingy, oh, I clicked it this time. If you look at all these linear functions, well, how do you zoom in? Press this, zoom, zoom. You can see it looks like that. And you also see the general form ax plus b. Take a look at that. Ax plus b, literally it is the exact perfect linear function type. Okay? Next one. 5x squared minus 1, we're going to classify that. Well, it's not this type. because there's no squared here. Let's go to see, is it exponential? That doesn't look right because the x is the exponent. And that's not what we're looking for. We want x as the base of the exponent and 2 as the exponent. Over here, quadratic, ax squared. Oh, look, x is the base, 2 is your exponent. Ta-da, we are looking at a quadratic function. And let's say you don't like this. Let's say you're better at looking at shapes. You're a visual learner. So then if you are a visual learner, you can always go into decimals and say 5x squared minus 1. What does that look like? 5x squared minus 1. And you're like, oh, that's the U-shaped graph. The U-shaped graph are the exponential graphs. You see how they're all U-shaped? So if you don't like looking at the formulas and you're not used to it yet, then get used to looking at the shapes and you can still use decimals and you will still get it right. So this is a quadratic function. Oh yeah, and by the way, this answer key for this thing, this was like 2 weeks ago, so you can't turn it in anymore. All right, classify this one. X is your exponent. So let's take a look over here. Notice in the exponential functions, your x is the exponent, okay? It's not the base, it's the exponent. Look at the equations that we have. X is the exponent, x is the exponent, x is the exponent. This is exponential. And once again, if you're a shapes person, you're a visual learner, type 3 to the power of x over here. 3 to the power of x. And then you can see it's the L-shaped graph. It's the exponential shaped graph. So there's 2 ways you can do this, either straight up by the formula or by the visual when you go on decimals. Okay? Just type in the chat if you have any questions. I'm looking down every once in a while. All right, match each function to its graph. Okay, so let's see. Well, if you don't know what anything looks like, let's type this in, absolute value of x minus 3. Absolute value, remember, is right here. Okay, x minus 3, close it, and close it. There we go. And you can see it's the V-shaped graph that moved from the center over to the right a little bit. How much to the right did it go over? Oh, look, it moved to the right 3. How interesting. We'll get into that later. But this is an absolute value function, moved to the right 3. Let's take a look. Which one is it? Oh, it's this one. So then we drag our answer there. Okay. Let's try another. F of x is equal to negative 2. So sometimes you have to type f of x. Let me show you. If you just type negative 2, nothing happens. So if that's ever the case, type the whole thing. F of x equals negative 2. And then you'll see, oh, it's a straight line, a flat constant line at the negative 2. Okay, let's see. Where do we see that? Oh, it's this one, top one. All right, let's see. Can I drag it? Okay, what if I drag it here, and then I drag it there, and then I drag it there? Okay, so here's what happened is I couldn't drag my equation all the way up there. It wouldn't let me. Like, it wouldn't let me. So I put it here, and then I just dragged it up, okay? So that's how I got it to the right spot. So that sometimes might happen to you, like it just happened to me, but if it happens, you just gotta problem solve and you gotta think on the spot. We found a solution. Drag it into the wrong box and then use those wrong boxes to continue dragging it up. Okay? So that's just what we do. We just think of solutions because we are problem solvers. All right, let's do the next one. Negative x plus 2 squared plus 2. Negative x plus 2 squared plus 2. All right, so if you can't remember the whole equation, no shame in going back and forth just to make sure you typed it in correctly. It's all good. But look, wait. Aw, dang. You know what? I didn't make this one. But there's a little mistake here, but the point is it's supposed to be the upside down U-shaped graph. My bad. I know it doesn't match exactly. Don't blame me. I didn't make this. But we all make mistakes sometimes anyways. Okay, so you can tell this was intended for this one. Right, let's do the last one. 2x plus 2 as the exponent, and then minus 1. 2 to the power of x plus 2. Oops. So if that happens, you can use your arrow keys. See how my cursor can go up or down? So I use my right arrow key, my left arrow key, and then it's a plus. Oops, that's not working. Okay, so sometimes that happens. What I do is I just type it in the front, x plus 2. Was it x plus 2? Yeah, it was x plus 2. There we go. Then go minus 1. Once again, if you have trouble typing in Desmos, just call me over. I'll help it. I'll help. Don't worry, okay? So look, it's a curvy shaped graph. Let me zoom out a little so you can see a little better. It's our exponential. So that's right there. Another typo? Okay, that's fine. All right, I need to make space, so I'm going to drag it up here. Now drag it up here. Drag your answer back. There we go. So that was a little complicated, but if you need help, just tell me what answer you want and where, and I will help you drag it. Hopefully we don't come into this problem next time. I'm gonna tell the other teacher so that we make sure we don't make a problem like this again. It's too many problems. Let's go next. All right, I know this video is long. I know this is a lot of me talking, but please bear with me. I will put you into breakout rooms soon so that you can do the next part of the class on your own. So you get a little bit of not listening to me time. All right, the graph on the left is, what is this asking for? Increasing, decreasing, constant, or a combination. So let's take a look. We have to go from the left side. So first on the left side, this section is going up. So this is increasing, and then it goes down, so then it's decreasing. So increasing, then decreasing. Increasing, then decreasing. All right, the graph on the left has either an absolute maximum or an absolute minimum or neither. Take a look at that top point. That top point is higher than every other point. This is a maximum, absolute maximum. The graph on the left is also a discrete or continuous. Discrete is made of dots, okay? So remember that discrete is made of dots. So I'm going to put discrete because the line has breaks in it. The graph on the left is a what function? It is a linear absolute value function. And what equation could be used to model the graph? Now these are your basic formulas. Remember that if you know it's a linear absolute value function, you go find the page on your graphic organizer, which is right here. And then, oh, A, absolute value of x plus B, absolute value, plus C. Okay, so that must be this one. Okay? Remember to just type your question if you have a question. But it looks like we're making good time here. I'm gonna go to the next one. Okay, so here we got a little curvy graph. On the graph on the left is, okay, let's see. Starting from the left, it goes down, 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 that's decreasing. Then it goes up, 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 that's increasing. So decreasing, then increasing. The graph on the left has, which one? So take a look over here. This point on your graph, it's lower than anything else on your graph, so that means it's an absolute minimum. The graph on the left is also a blank graph because the line has no breaks in it. So if there's no breaks in it and you can trace over it without lifting up your pencil, just imagine it's on a paper, then you have a continuous graph. The graph on the left is a blank function. So this is the U-shaped graph. If you ever forget, go to your answer key, no, sorry. Go to your graphic organizer and you're like, oh, that's not right. Oh, these are U-shaped graphs. Okay, what are these? Quadratic functions, okay? Where did I, oh, it's right here. Come on. There we go. And what function or what equation models the quadratic functions? If you forget, go back to your graphic organizer and take a look over here. Ax squared plus bx plus c. Notice the 2 as your little top right-hand corner. The 2 is your exponents. That is the key to the quadratic function. So we're going to go put that in right here. Okay, so far no one's typing a question. Let's go to the next one. Alrighty, take a look at this. It goes dot, 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 and then it starts dropping down. It looks like a ball just falling, right? The graph on the left is, start from the left, go all the way to the right. The entire time it is decreasing. It's always going slightly lower, 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 and then it really goes low, really fast. The graph on the left has, okay, I don't know, typos, sorry. So this is an exponential function. Remember, exponential functions do not have absolute maximums or minimums at all, ever. Graph on the left is also a discrete graph because discrete is made of dots, okay? Lots of dots. Think of D for dots, D for discrete. The graph on the left is an exponential function. Remember, if you forget, where can we look? The graphic organizer, okay? So we can look on the graphic organizer. Let me show you the exponential page. Look, this one's made of dots, looks just like it. And these are made of continuous lines, but they still look the same. They're just a curvy L shape. So these are your exponential functions. And which one could be used to model a graph? If you forget, look at here, scroll up. You'll get a times b to the power of x plus c, where x is your exponent. So then you can find the correct answer right there. And last but not least, I know you're just like, come on, Miss Jade, you're talking so long. Last question, we're almost there, so bear with me. The graph on the left is, start from the left, go all the way to the right. It's only going down, down, down. That means it's decreasing the whole time. The graph on the left has, linear graphs do not have a maximum or minimum. Okay, if you lagged, it's not your fault. I will upload this onto the video later. So what you have to do is just do the next assignment and watch this, sometime tonight when I upload it, okay? Tonight or tomorrow, you watch this video. So the graph on the left has no maximum or minimum. The graph on the left is also a continuous graph because the line has no breaks in it. Continuous is not made of dots, it's all connected. And if you were to trace over it with a pencil, you do not have to lift up your pencil at all. Just imagine yourself tracing this. If you don't lift up your pencil, you got a continuous graph. The graph on the left is a linear function. And if you go take a look at your answer key for the graphic organizer, right over here, you will find that our linear functions have this form, ax plus b. So this, okay? And then we can submit. So that was it. Let me stop the share and end recording.